First, I'm going to explain the UPAC. The International Union of Pure and Applied Chemistry, or UPAC, serves to advance the worldwide aspects of the chemical sciences and to contribute to the application of chemistry in the service of humankind. As a specific, international, and non-governmental and objective body, UPAC can address many global issues involving the chemical sciences. The hydrocarbons are named in accordance to the UPAC Convention. In the naming of hydrocarbon, it is important to name the hydrocarbons correctly so everyone knows what you have in your chain. The rules are very important. They are universal rules so anyone can understand them. Some common hydrocarbons are methane, ethane, ethene, ethine, propane, and propene. Hydrocarbons are separated into groups, aromatics and aromatics. The aromatics group contain alkane, alkene, and alkyne. Alkane are the groups that have at least one single bond. Alkenes is the group that have at least one double bond. And alkynes are the ones that have at least one triple bond. Now, in the aromatics, they contain the same bonds. There are bonds that contain 6 carbons. Hydrocarbon derivative is a compound with a carbon molecule and at least another element that is not hydrogen. Okay, so here I'm going to do an attempt of chart to give some examples of the alkanes, alkenes, alkynes, and aromatics. So in the alkane, remember it just have a single bond. So here I'm going to do an example with 2 carbons and 6 hydrogens. 2 carbons and 6 hydrogens. So you can see that in the middle is just a single bond. So that's why it's alkane. So another example we're going to do It's just a single carbon with single bonds. So here in the alkene, we can see a double bond in the middle, bonding two carbons with two hydrogens each one. Okay, so just ignore this. I just committed a little mistake. So we're going to add another carbon with a single bond, it doesn't matter. And we're going to add hydrogens. And you can see in the middle the double bond. Now, in the alkynes, we remember that it has a triple bond. It must have at least one triple bond. So, here you can see the triple bond after the C, between the C's of carbon. And then we're going to do another example. Again, the triple bond in the middle. It doesn't see correctly in the camera, but there are 3 lines of 3 bonds. Okay. And we can add, if you want, another single bond here with a carbon and hydrogens. It doesn't matter, it's okay. Now in the aromatics, it can only have 6 carbons, so you can have more, you can have less, just 6 carbons. So let's try. So just let's draw a hexagon with double bonds in the middle, like that, and that's an example. And you can put more benzene rings, that is called, together, and doesn't matter, but they it's like the figure just can have 6 carbons, not more, not less. Here's another attempt of doing an hexagon shape. Here it is, and that's it for the examples.